All right, Mr. Arnold back here. Taking a look at electricity here and some things that you need to know about electricity for our first real formative assessment that you're going to be taking. Will made an attempt doing a review video for me, and he did actually a really good job of explaining. I'm going to touch up on a few things, and then you should be ready to go for the first formative assessment. First of all, we need to know the differences between insulators and conductors. And it's pretty simple, as Will said. Insulators, they don't like to allow things to flow through, so they don't allow those electrons to flow through. And I'm going to put a little abbreviation for electrons there. Where conductors, however, allow electrons to easily move through a substance. So insulators, things that are really good insulators, obviously rubber, plastic, wood, are good insulators. If you think of things like electrical cords that are wrapped in a plastic or rubber material to keep electricity from flowing through. If you think of like even cooking utensils, even though we're talking about thermal energy and not electrical energy, a lot of your pots and pans have some sort of rubber or some sort of material on the handle, plastic on the handle to keep the heat from moving through, so that an insulator doesn't allow electrons or energy to flow through where conductors do. Biggest conductors are metals. That's why our wires and stuff are made out of some form of copper. It could be any type of metal at that point in time. So just understanding the difference between conductors and insulators and how those actually work. Next thing that we really need to kind of understand is a little bit of the difference between static versus current. And I'm also going to add in the word here, circuit, finally, electricity. Static, if something is static, it is not moving. And static electricity really is that. It doesn't really move. The only time it moves is when it actually discharges. And it's the buildup of electrons. So if you take your feet and you drag your feet across the carpet and you're in socks and stuff, you have a bunch of extra electrons that jump up on you, and then you move over to a metal object or maybe even your little brother or sister and you touch them and you shock them, you have worked with static electricity. All right? So static really doesn't move. It builds up of electrons, and then when it and I'm going to say release, we call that static discharge. And one of the biggest examples of static discharge is what you see out at storms when it's actually lightning. The clouds are building up electrons as the molecules are moving up and down inside of the cloud, and then once there's enough electrons that build up and it gets close enough to the ground, it can discharge and create that lightning bolt that you see. Current electricity is simply just flow. Electrons moving. Okay? Current electricity, there are two major types that we will talk about. You'll learn about them later. Series, where there's only one path, and then parallel, where there is more than one path. Mr. Carson, what's up?
I'm going to say hi. Hi, people in the video.
Carson says hi, people in the video land or wherever you are at. So static electricity doesn't move, buildups of electrons. When it does release or move, we call that static discharge. And lightning is a perfect example of that. Current or circuit electricity is the flow of electricity, and there are two types. One is series. In series circuit, there's only one path for the electrons to move. Parallel is there are multiple paths for those electrons to actually move. Another little thing to talk about is how we can build up static electricity. So we'll kind of come back here, and we can build up static electricity, or not necessarily static electricity, or how we can transfer electricity, I should say, via two processes, induction and then conduction. Induction is where we get close, but we don't touch. and we simply induce a charge on an object. And I'm running out of room to write it. Conduction is where we actually touch to get a charged object. And so what I mean by that is, separate those two right there. Induction, if you've ever walked by your TV and you felt like the hair on your arms or something kind of stand up, but you didn't directly touch your actual TV, that induced a charge on the hair on your arms and caused them to kind of stand up, actually repel themselves. Where conduction is where you actually touch the object. So I put my hand on the TV, I get a shock, and that causes me to become a little bit more negatively charged there. So we can induce a charge through induction and cause objects to become positive or negatively charged, or we can actually physically touch the object, called conduction, to make it positive or negatively charged. Alright, so a couple more things that you need to know out of this first unit here. Just a little bit about electrical forces versus other forces, more specifically gravity. Electrical forces are actually much, much stronger because the interaction is at such a small level. Gravitational forces are much, much weaker because most of those forces are over great distances. Oops. Sorry about that. What I mean by there is the gravity between the Earth and the Sun, or the gravity between the Earth and the Moon. There's such a great difference. While there's a great amount of force there, it seems weaker to us than the electrical forces between a proton and electron. There's such a small difference there. They're much more highly attractive, and you can influence an object's behavior based off of those electrical forces. Final little thing, and this instrument is called an electroscope, and it's really just a box that has two little leaves that are on there. The two leaves are typically some sort of metal, and if I bring an object towards the top of the electroscope, how these leaves behave tells us what type of charge is on the electroscope. Okay? And so if I bring an object close to the top here, and let's just say this object is a metal pole that I have charged positively, it's going to cause these negative electrons to want to come towards the top, and those leaves will fall towards each other. If I do an object, and this time, instead of the object being positive, let's say I make it negative, it's going to force these electrons to move down towards the bottom and causes those leaves to spread apart. So by looking at an electroscope, I can determine the charge of the object that is near it. Remember, the electrons are the only things that are moving. So if I bring a positive object close to the top, it's going to want to pull, because the attraction of opposite charges, the electrons to the top, which allows the leaves to shut. If I bring a negatively charged object towards the top, it's going to force the electrons to move down towards the leaves, and again, opposites repel, they don't attract. So that's how an electroscope works. I know it's been mentioned, just so you have an idea of what that is. As always, if you got any questions, don't hesitate to ask.